Okay, here we go. We're going to correct the homework you had last night. Before we get started on the correction itself, let's make this note. All of our answers are going to be rounded to the nearest tenth if necessary. So let's zoom in on problem number 1 and take a look at how we would solve that problem. So what we're doing is, and again, remember these are compound figures, which means we're looking for standard figures, things like rectangles, triangles, trapezoids, and circles that were combined together to make this figure. So when I look at this, I think of having two rectangles. I have this rectangle and I have that rectangle. Anytime I am working with rectangles, so when I want to do work with rectangles, I know I need a length and I need a width. This is going to be my work for rectangle 1. So for rectangle 1, my length is 12 centimeters. I don't need to put the unit of measure right here. I can just keep track of that. My width, 4.5 centimeters. So I'm going to multiply 12 times 4.5. So let me get my calculator. I'll shove it way over there. And I am going to have 12 times 4.5. That will be 54. Now I bring my label back. That will be 54 square centimeters. This is a measurement of area. My second rectangle, my rectangle 2, also a rectangle. You know, I write that down because it just helps me remember, because anytime I write triangle or trapezoid down, I know I have to do something different. So rectangle 2 has a length of 5 and a width of 2. This 2 is the measurement in both those corners. 5 times 2 gives me 10. Let me write that a little more neatly. Gives me 10 square centimeters. I'm going to put that 10 centimeters together with this 54 centimeters, and I'm going to end up with 64 square centimeters. All right, down to problem number 3. So in problem 3, I'm identifying two shapes. I have a triangle and I have a semicircle. So this will be shape number 1. This will be shape number 2. Let's zoom in. Now we're zoomed in enough, I think. We'll stick with this. So shape number 1. Shape number 1 is a triangle. So for any triangle, I need to know a base and I need to know a height. Here the base, well, this piece right here is 8 centimeters, which means if I went all the way across this, if I was finding the bottom of that triangle, I would be looking at 16 centimeters, and I've got a height of 15 centimeters. So I know the math is going to be 16 times 15 divided by 2, because anytime I'm dealing with triangles, I'm dividing by 2. 16 times 15 is 240 divided by 2, and half of 240 is 120. So I have 120 square centimeters of triangle. All right, now the circle. Let's get rid of that. Now the circle. I'm going to get rid of that as well. So we have a circle. This is number 2. It's a circle And for circles, I need to know the radius. And here, from the center to the outside, is 8 centimeters. I'm going to apply this formula. I'm going to apply the formula pi times the radius squared. My pi is going to be 3.14 times 8 times 8. That's my 8 squared, my radius squared. I'm going to multiply that together first. I get 64. So I've got 3.14 times 64, 3.14 times 64, which gives me 200.96. So I've got 200.96. I'm going to take that amount, and that's also in centimeters squared. Now, I have to divide that in half. Why am I dividing it in half? Because this is the formula for the area of a circle, but I don't have a whole circle here. I have a semicircle here. So I'm going to divide that in half. If I divide that in half, I get 100.98, or 48. I said 98, I don't know why. 100.48. So now I'm going to add that, going to add this. So I've got 120 plus 100.48. Add those together. I get 48,220.48. Remember my instructions at the top, round to the nearest tenth when necessary. Well, the tenths place is right here on this 4. The 8 tells me round that 4 up. The 8's more than halfway to the next number, so the 4 becomes a 5, and my final answer is 220.5. I'll put it right up here. 220.5 square centimeters. That is my answer to problem number 3. Now I want to encourage you, if at any point here you realize, oh, I was doing some of these wrong, I see my mistake, then stop and redo the problems that are left. Don't automatically just go along and correct things that you know you got wrong. If you know that you did it wrong, go back and fix it, and then watch the video to correct it. Okay, so let's take a look at question number 5. So when I look at number 5, I see that I have 2 shapes. I have a triangle and I have a trapezoid. So let's work on the triangle first. I know that if I am solving a problem that deals with a triangle, I need 2 pieces of information. I need a base and I need a height. The base of this one is pretty straightforward. It's that 7 feet. The height is a little less straightforward. It's this distance right here from where the base comes across at a right angle up to where the top would be. Another way to think about that, let me get my 1 out of the way. Another way to think about that is right from that point down. Now, the reason I drew this line out thinking of the base, or thinking of the height I mean, is that it kind of fits with that 6.4. What I see is this 6.4 is the whole thing. This amount of this trapezoid is 3.6. So what's left of that from here to here is the actual height of this triangle. So to get that, I'm going to have the 6.4 and I'm going to take away the 3.6. So borrow from that. 14 take away 6 is 8. 5 take away 3 is 2. my height is 2.8. So to get my triangle, I'm going to have 7 times 2.8 divided by 2. 7 times 2.8, 19.6 divided by 2, and 19.6 divided by 2 is going to give me 9.8. So my triangle is 9.8 square feet. All right, now my trapezoid. So trapezoids require the most complicated formula, but once you use it a couple times, you can do this. It's not outside of your ability. So number 2, that shape is a trapezoid. The thing that tells us it's a trapezoid is it has these 2 sides that are parallel. So this where the 7 feet is marked and where the 9 feet is marked. Those are parallel. Those are called its 2 bases. For a trapezoid, this would be base 1 and this would be base 2. The formula for a trapezoid is the area equals 1/2 of the height, in this case 3.6, times base 1 plus base 2. So that tells me when I'm solving a trapezoid, I need 3 pieces of information. I need a height, I need base 1, and I need base 2. For this trapezoid, the height is 3.6, base 1 is 7, base 2 is 9. So I'm going to plug those in. Now, for me personally, when I see multiply a half, I think divide by 2. It's the same thing either way. Dividing by 2, multiplying by a half, they mean the very same thing. So you can do whichever one you're most comfortable with. I'm more comfortable with dividing by a whole number like 2 than multiplying by a fraction like a half. But you do it whichever way fits for you. So here's what I know. I know I'm going to have 3.6. I'm going to have 1/2. I'm going to do the 1/2 way this time. Times 3.6 times base 1 plus base 2, the 7 plus the 9. So I haven't used that yet. I haven't used this yet. That's 16, the 7 plus the 9. So now I'm going to have 1/2 times whatever 3.6 times 16 is, which is 57.6. 1/2 times 57, so multiply that by 0.5, which would be the same as dividing it by 2, gives us 28.8. My final step, by that's square feet, my final step is to add this number, what I got from the triangle, and this number, what I got from the trapezoid. So I have to add those numbers together. 28.8 plus 9.8. 8 and 8 is 16. Bring down my decimal, carry a 1. 1 and 8 makes 9, and 9 more makes 18. Carry a 1. 38.6. Bring it up to the answer line here. 38.6 square feet is the answer to number 5. All right, let's move on to problem number 7. So on problem 7, I'm going to have to change the zoom on this a little bit. Let's see if that gives us all of problem 7. There we go. Problem number 7. So we are given this deck that Daniel is constructing, and we need to go ahead and figure out its area. So there are 3 shapes here, and I grabbed my line tool a moment ago. build them. So if I drop that and that, you can see that what we've created are two trapezoids and a rectangle. For the trapezoids, so remember, when you do a trapezoid, you need to know the height, you need to know the first base, you need to know the second base. So the height, they tell us, is this 3.5. So we know that the height of our trapezoid is 3.5. We have a base of 5, and we have a base of 12. So my formula is going to be 1/2 of 3.5 times, so 1/2 times 3.5 times the sum of the bases. Well, in this case, the sum of the bases is 17, so I have 1/2 times 3.5 times 17. Now I'm ready to have a calculator out. 3.5 times 17. I have 1/2 of 50, premature decimal point there, 59.5, multiply that by 1/2, and we get 29.75. So that 29.75, I'm going to put my total, I'm going to use this to make my total. That 29.75 is the total of trapezoid 1 and trapezoid 2. In fact, so I bet somebody out there has already looked at that and said, wait a minute, if you have them both, you didn't multiply by 1/2, you just keep the 59.5. I could have done that, but I want to show all my steps. All right, and then my rectangle. So number 3, my third shape was a rectangle. And for rectangles, you need the length and the width. Well, the length of the rectangle is 12, and the width, they tell us this is 5, and you can see the figure is consistent all the way around. So this is also 5 feet. So I have 12 times 5. That gives me 60 for the rectangle portion. I'm going to go ahead and just move this up a little bit. Add all of those together. 5 and 5 is 10, carry a 1. 7, 14, and 1 more is 15, carry a 1. 10 and 9 is 19, carry a 1. 1 and 2 makes 3, and 2 makes 5, and 6 makes 11. There's my total. I'm going to write it here a little bit larger. 119.5 square feet is my answer to number 7. Got that goofy pen going on again. That's my answer to number 7. 119.5 square feet. All right, last problem, number 9. And I think from looking at number 9, it's going to be easier than number 7 was. Let me get a big view of number 9 here. There we go. Get my calculator over out of the way a little bit. So here we have 3 rectangles, and this is a problem where we're actually taking pieces away. We're not adding pieces in. So I see 3 rectangles. I see a rectangle here and a rectangle there. I'm going to be taking both of those away eventually, and I'm going to be taking them away from that rectangle. So I can do this in any order, and I'm going to start by the one I'm keeping. So I'm keeping rectangle 3, and it is, so it's a rectangle, And again, anytime you're working through one of these, you're listening to my answer and you think, oh, that's what I forgot to do, then just pause the video and do it and then check your work. So for every rectangle, you need to know the base, 13 or the length, and you need to know the width, that's 7 right there. 13 times 7, 7 times 10 is 70, 7 times 3 is 21. I think this is going to be 91, but let's just double check. There you go, 91. 91 square centimeters. If neither of these white sections were taking away from that, that would be my answer. But I do have those white sections. So the first rectangle that I am taking away, I also need to know its length and its width. Well, its length is 4. Its width is 3. So I've got 4 times the 3. That is 12 square centimeters. So I'm taking that away. I'm also taking rectangle 2 away. And again, I'm going to make sure I write down the length 2, the width 1. 2 times 1 is 2 centimeters squared. So here's what I've got. These are the things I'm taking away. 12 centimeters squared, another 2 centimeters squared. I'm taking away 14. I'm taking that away from 91. So borrow or regroup from that gives me a 7, 8 and a 1, another 7. My answer is 77 square centimeters. And yeah, that felt a lot easier than problem 7. Trapezoids are the most work, but you'll get good at them. Remember, you get a page of notes on the test. If it were me, I would absolutely positively have the formula for trapezoids in my page of notes. And I would also have the formula for circles and triangles, maybe even rectangles. All right, there you go. So study this. Look at which ones you had the most difficulty with. Those are the ones you really need to concentrate on. You're going to see questions like this when the test rolls around, and you're going to see them later in 8th grade math and high school. Okay, great. Be sure you have any questions you let me know about.